So we've seen this before. It's the most important thing about combinations is deciding whether or not the order matters. And we're going to sort of see which types of questions most commonly come up where the order doesn't matter. Sometimes it'll say in the question, the order doesn't matter. Other times it will ask specific things like making groups of students or making committees. Because if you make a committee of 3 people, the order doesn't matter. Sometimes the order will matter if you're making a group of 3 people and one person's going to be president of the school, someone's going to be vice president, and someone's going to be the treasurer. Then all of a sudden the order does matter because there's different roles. But if you're just making a group of 3 students and you say, can I have a new group, and I tell you the same people in your group just in a different order, you won't be very happy with me. And we saw this already too. What is happening with the order, and I need a little bit of white out here because there's not a line there, so you can scribble that out. And choose R is just your permutations with dividing out the order. So if you're choosing groups of 3, you would divide by 3 factorial from your permutations to get rid of the order. Here's some special cases. If you have n objects and you get to choose all of them, there's one way to do that. Choose them all. If you have n objects and you choose one of them, there's one way to do that. Or not one way, there's n ways to do that. Because you have like 52 cards, choose one of them, there'd be 52 ways you could do that. So some of them you can do quite easy with mental math. And then here is what we saw before, that n choose n minus r, and we saw it with 10 choose 6, that's going to be the same as 10 choose 4. As long as these 2 numbers add up to this number, they're going to be the same. Because every time you take a group of 6 from 10, you're left with a group of 4. And that's in your notes as well. And you can see it from the formula. So a very common combination question is playing poker. Because when you're playing poker, you get dealt 5 cards, but the order doesn't matter. As soon as you get dealt those cards, you can rearrange them in your hand. It doesn't matter if you got the ace of hearts first or the ace of hearts later on in the hand. So if we want to figure out how many different poker hands are possible, there's 52 cards. You just need to choose 5 of them. Almost 2.6 million different hands. So another typical combinations question is a committee question. Because a committee, the order doesn't matter. If you're on the committee. Now, sometimes you'll get these questions. You got 2 boys and 3 girls is to be selected from a class of 15 boys and 18 girls. How many ways can this be done? Well, there's 2 decisions to be made. You've got to choose which boys and which girls are going to be on the committee. Choose 2 and 18 choose 3. And you go to your calculator, figure that out. You've got the answer already?
Yeah.
How much? 85,680. Awesome. So let's say you have a class of 20 students and you want to put them into 3 smaller groups, but one group has 8 students, one group has 5 students, and one group has 7 students. The order doesn't matter. So how many decisions do you have to make? 3. What do you want to make as our first decision? Group A, then Group B, then Group C. How many ways can you choose 8 students to be in Group A? 20, choose 8. Because there's 20 in total, this means everybody has a possibility of being in Group A. Does that make sense? There's 20 students in total, and you choose 8 of them. Now, Group B will not be 20, choose 5. Why not? Because you already chose 8 to be in Group A. So there's 12 left. Now you choose 5. Now how many students are left? 7. So you could write, if you wanted to, 7 choose 7. But whoever's left is going to be in Group C. So you could also say times by 1. And we're going to get a very, very big number. Now this question, we could have had this question in our permutations unit. How could we solve this one as permutations? You could imagine all 20 students lined up in a row, and you have 8 A's to give out, 5 B's to give out, and 7 C's. You could also solve this same question as a Mississippi question. There's 20 letters, right? That would be 20 factorial, but we have repetition. Because you could say, first 8 students, you're all A. Next 5 students, you're all B. Last 7, you're all C. Or you could figure out all the different arrangements of A's and B's and C's, and that would give you all your different groupings. And so that would be 20 factorial over 8 factorial, 5 factorial, 7 factorial. And just to show you that these two are the same,
Pardon the interruption, but can we have all the grade 12 down to the cafeteria time for your ice cream bar as we work for champagne? Thanks so much. Have a great day, everyone. Do you think we should take our stuff?
yeah. Now since 7 choose 7 is 1, that is the factorial representation of 20 choose 8 and 12 choose 5. Can you see that the 12 factorials would simplify, and you've got exactly the same as if you would solve it as the Mississippi question. So in a question like this, as long as you have an explanation, you could solve it either way. So we got a couple more questions here. Find the number of, oh, should we wait until Tuesday?
Yes.
Okay, you can work on the homework. I'll give you an additional handout as well.